I don't see like on the quality level there are huge difference. I feel like 27 billion model is more professional. My name is Han. I run the model training and inference team at Elastic. We know that Qwen3.8 was just released last Friday, and I want to make a side-by-side comparison against one of my favorite models all the time is the Qwen3.6 35B A3B. In particular, I want to test out how are they going to perform under the agentic search scenario. So I prepared some private data, and I have optimized both models on the low-budget GPU like NVIDIA L4 on GCP, mostly because it's cheap. It is down to like $0.1 per hour. It's pretty cost efficient, and so the memory bandwidth is a little bit small. It's only 300 gigabytes, right? So if you are interested in how I deploy these two models on L4, here are the repositories that you can check out. 35 billion A3B model is an MOE model, which gives you like after optimization, it gives you like a 90 tokens per second up to 100 tokens per second on decode. On 3.8, 27B is a dense model, so it gives you like a 23 tokens per second for decoding. The maximum context length is much bigger. And in terms of the software that we are using, it is basically a private harness. Here are the two open source projects that you can check out, which basically serve as the foundation of the private harness that we are going to see. So one of them is the data room, the other is a search box. So I'm basically writing some very thin harness layer, which relies on the system prompt alone. And if you follow my previous work, so you probably already know what it is. One of the most interesting part of evaluation is that you should not evaluate against the public benchmark. You collect your own corpus, which you know the best. So to me personally, I found Jina in 2020, and I've been like knowing everything about Jina in the last 6 years. So I can confidently say that nobody knows Jina better than me. Therefore, I can easily use this information to evaluate who can do better agentic search. Let me repeat this again. So this is very important. So we want to evaluate a scenario where we give the model a data room, and the model kind of gets itself locked in the data room, and it keeps searching, analyzing, reasoning, writing programs, or it cannot access the internet. The only information that it can access or it can derive from is basically the corpus that I gave it to it. Right. So this is basically the interface is pretty standard, but in this example, we are mostly interested in this A/B test. In particular, we are interested in like all the tool calling traces, the time span, and all this kind of stuff. Here you can see the two models name. One is a 3.6 35B A3B, and the other is 27B 3.8. Both of them using the same quantization is Q4 4-bit quantization KXL with multi-token prediction, like speculative decoding. And so we can just create a new session and then put the question here. What is the problem between the image text in Jina click v1 and v2 that have not been solved but later get solved in Jina embedding before? By the way, the answer is modality gap. As you can see, the 3.6-35B goes much faster because its decoding speed is like 90 tokens per second, it's much faster. So it already finished like 34 seconds and spent like 26,000 tokens, which involves 3 turns. Well, and on the other side, you can see like a 3.8, 27 billion dense model is still running. So let's wait a little bit. Apparently, this 3.8 27 billion model also point out this it is modality gap, which is correct. And it also points out the like V4 abundance. Also, okay, so it outputs some statistic here, but also it's very important that both model points out that it solves the modality gap because they abandoned the V4 model abandoned the dual encoder design. I don't see like on the quality level there are huge difference between these two. even though just by reading at this, I feel like 27 billion model is more professional in terms of the tones and terminology, academic tones. So if we look at the time spanning and token spanning, we can see that this 27 billion dense model is much, much heavier than the 3.6 MOE model. Right? It costs 70,000 tokens, while the and 3 minutes. Right here, it only takes 30 seconds. So basically, so it's basically like 6 times longer than the 3.6 model. So let's try another question. So the question here is, what was the first model Jina released that switched from Apache 2 to CC by NC license? This is a kind of like a hard question. You kind of have to look back from all the models that we released and found out their corresponding license. The point when we switched the model license. For MOE model, we already get the answer, right? And the answer is Jina Reranker V2 based multilingual. So starting from June 25th, 2024, we start to change the model from the Apache 2 to CZ by NC, which is correct, right? Qwen3.8-27B model also gives the result. And as you can see, it also points out the correct date, 2024, June 25th, which was the first Jina model released under CC by NC, switching from the Apache 2 license used by all earlier models. So both of them get this correctly. I don't think there's a huge difference, in terms of the quality, I don't think there is a huge difference between them, right? So if you present me these answers by masking the model name, I cannot really tell the difference, right? So here's the interesting part. Both models finish more or less the same time, but apparently 3.8 model use much less tokens, right? And it also has just much less turns. So you can see that the MOE spend mostly on the search, right? Search corpus. But for 27 billion model, it only calls search corpus one time. And it also didn't read anything. So here in this case, you can see this read gives the offset and limit, which is very nice. But otherwise, the read basically reads a whole document into the context. For the MOE, it spends too much time on the pre-filling because it's read a lot of context from the disk, from the files, and then try to load them into the context window. I think this is a very good example to show that, okay, even though both model gives the right answer, but how do they get there is very different. So this question is a binary question, a yes or no question. So it asks whether, so we never have Jina Colbert v3, but it is essentially just Jina embedded v4. The answer should be yes, but it's debatable, right? So you have to really understand that Jina embedded v4 does support multi-vector output, right? And then Colbert is basically a multi-vector model, right? And therefore, the answer is yes. But it's also debatable in the sense that Jina embedding v4 is not really heavily campaigned as a multi-vector model. And the first-class citizen, in terms of the UI or UX or API, it is always a single vector. So in that sense, if you only read the press release, so you will say that, okay, the answer is no, apparently they're different, right? But you have to really dig into the Jina embedding v4 paper and then understand that, oh, this is actually multi-vector. It has some a head MLP head on top of the last transformer layer, which makes it essentially a Jina Colbert model. And you also have to understand that we do have Jina Colbert v1 and v2. So v3, we don't have v3. So to understand where this question comes from. As you can see, the 35B A3B model has already finished. And it answers this correctly. It says, first, it identifies that Jina Colbert v3 was never released. And it is essentially just embedding v4, right? And because multi-vector embeddings in the latent interaction style. So it also points out the right citation, reference, and so on. So 20 seconds, 4 turns, 24 tokens, 24,000 tokens, which I think is pretty nice, right? Okay, so now the 27 billion dense model has also finished. It also answers the question in 2 parts, right? This is, I don't know, this is happy coincidence. As you can see, like in terms of the answer, structurally, they are surprisingly similar. So as you can see, this is pretty fun to look at. And but what is more important for me is actually to look at the trace. So for example, if I want to look at the thought process here and then compare this side by side, and also the tools it calls, right? So even though both are like a search corpus, but you can see the query here is also quite different. The MOE model sends out is directly search for Cobalt v3 and jina embedding v4. The 27 billion dense model sends the first query as jina Cobalt v3 release or not, and relationship to jina embedding v4, right? Which shows a little bit different thinking process. Okay, so let's phrase it this way. So some of you probably already know that I keep talking about search as test time compute and high quality search as test time scaling, right? For me, what is really important in agentic search is we look at the two calling trees from those large language models and think about how can we improve each step to minimize the time cost or token spending. Whether some of the traces or some of the composition are reusable, can be built very easily and reusable over time, right? I think this is the next step of the test time scaling of the search, to think about how can we optimize our embeddings and rankers for the agentic search solution. For example, one thing that I learned when I built this, the embedding API should return the line number or the offset to the large language model. This helps the large language model to use the grep tools as immediate next step. I believe such optimization exists in a lot of places. As model developer of embeddings ranker, OCR model, data ingestion model, we have to think about how can we better make those small language model as the hands of the large language model in order to improve the agentic search performance. I hope you enjoy this and see you next time.